Gould Award lecture. Benvindo. It's actually a great honor for me to be introducing our award winner for this year, Professor Francisco Ayala. I'm going to say a few words about him. In some ways, I feel that anything that I might say is going to be a bit redundant because we all know who he is. We all know what his accomplishments are, but nevertheless, I think that there are some things that are worth saying. If we go back in time, before he became an evolutionary biologist, for a short period of time, he was a Dominican priest, and as such is uniquely qualified to comment on the relationship between religion and science, which is something that he's done at great length in the course of his career. He did his undergraduate work at the University of Salamanca, a nice place if you ever get a chance to go there, and then came to the United States to study with Theodosius Dobzhansky at Columbia University. And it was there that he started his work on Drosophila population genetics. And actually, I think it would be not an exaggeration to say that Francisco Ayala is part of that postmodern synthesis cohort that defined evolutionary biology as we know it today. So another reason why it's a particular honor to be introducing Professor Ayala. At the time I was starting my career, he was already an eminent Drosophila geneticist. And in fact, if he had done nothing else but be an eminent Drosophila geneticist, we would still all know who he was. But he actually did a lot more than that. He's, first of all, in his science, he's moved through many different areas, including most recently studying disease biology and areas that are of obvious deep social relevance in that respect. He's been an ambassador of science in many different ways, both in terms of looking at relationships between religion and science. He's been an ambassador between North American science and South American science, or across language barriers. He's published extensively in Spanish as well as English, both popular press and scientific literature. He's published in Italian, he's published in French, and all of this is one of the things that helps to break down barriers in terms of people understanding and having a common understanding of science. And I think this also is significant. In terms of public engagement, much of his work has been directed towards public engagement. And I think actually looking at another form of engagement, his work in policy engagement has been significant. He's served on President Clinton's Science Advisory Committee. Through his work with the National Academy, he's been involved in many papers that have gone before Congress, all promoting science, promoting understanding of science, and not just the scientific community, but representing the scientific community to government and to other agencies. And in fact, something that in many respects is invisible to people in scientific practice, but actually is having a significant impact on all of our futures. He's not gone unrecognized for this. In 2001, he was awarded the National Medal of Science in the United States. He's been appointed to the American Academy of Arts and Sciences, the U.S. National Academy of Sciences, and also the American Philosophical Society, and at least 6 other national academies around the world. Multiple honorary degrees. At his current institution, University of California, Irvine, in addition to having the Science Library named in his honor, he holds 3 different professorial titles: Professor and Donald Brennan Professor of Biological Sciences, Professor of Philosophy, and Professor of Logic and the Philosophy of Science. So we're looking at someone with a very broad perspective and also a very strong history of engagement outside of mainstream population genetics and evolution, but actually expanding into a much broader arena, including public engagement. And for these reasons, it's my great pleasure to announce that Professor Francisco Ayala is the 2015 Society for the Study of Evolution Gould Award winner. And I'd like to call Professor Professor Ayala forward.
Thank you, Professor Miguel, for the kind introduction. Thanks to the officers of the Society for the Study of Evolution for this award. It is a great honor and is particularly significant to me because I was a very close friend of Steve Gould. We met when we were both students at Columbia University. He was in the Department of Geology. I was in the Department of Zoology, as it was called then. But we met actually in a course in mathematics. And we became friends in then. He was also very interested in philosophy. In fact, one of his majors in college had been in philosophy. And we remained friends ever since, and we have interacted through the years in many ways. We both participated as science witnesses in the Arkansas Little Rock trial, where the teaching of creation science in the schools that was mandated was declared illegal. We traveled through many cities throughout the world in 1982 and celebrating the centenary of Darwin's death, and so on over the years. And it's a very special honor, therefore, for me at this personal level as well as in general, as in a broad sense, to have been honored with the Steve J. Gould Award. So, Professor Miguel, officers, and all members of the Society for the Study of Evolution, and all of you here, many thanks. On April 28, 1937, relatively early in the Spanish Civil War, Nazi German airplanes under the command of General Franco bombed and destroyed completely the city of Guarujá in the Basque Country. The Basques had opposed the coup d'etat that had just been initiated by Franco, and that was one of the reasons for the bombing. Another one was that the Germans the Nazis were starting to try the weapons, the new weapons that will be used in the Second World War that was anticipated, and that indeed started 2 years later. 25% of the population died. Women, children, men. Picasso, the great Spanish painter, had been commissioned by the Republican government in Madrid to paint a mural for the world exhibit that was going to take place in Paris in October of that year. In hearing of the massacre, Picasso, in the rage, the fury, the creative feat, he sketched in 12 days, this enormous painting, which is more than 23 feet by 8 feet, and eventually, of course, this painting went to the world exhibit in Paris, and from there he went to the Metropolitan Museum of New York, and after Franco died and the democratic government was introduced in Spain, was finally gone to Spain, where it is now. Well, we would all agree that this painting exists for the purpose of conveying a message. The horrors of war, the brutality of humans to each other. If it were not with this purpose, it would not have been created. And also it was designed by a particular individual, in this case, Pablo Picasso. In the same way, a watch has been designed to tell time, and a car has been designed for transportation. These are the letters of the alphabet, as you can see, and the digits. These are butterfly wings. Now we could use these letters to write text in English or in Portuguese, and the numbers to make arithmetic calculations, but obviously they have not been designed for that purpose. In the same way, we can use a mountain for skiing, and the rivers and oceans for navigation, but that's not why the rivers and the oceans exist. What about the human eye? The human eye has something in common with the painting, and the car and the watch, and something in common with the butterfly wings and the mountains and the seas. What it has in common with the painting is that if it were not for the purpose it serves, it would never have come to exist. The eye exists because for the purpose of seeing, and is the reason why the eye came to be. What it has in common with butterfly wings and the mountains and the seas is that it was not the result of an intentional design, but rather that came about by natural processes. Some understanding, of course, we owe initially to Darwin more than anybody else. There is a narrative in the history of science that says that there were two great revolutions in science, the Copernican and the Darwinian revolution. According to this narrative, the Copernican revolution was initiated when Copernicus published the day of his death, the year of his death, this book on the revolutions of the celestial bodies, written in Latin, sort of books, scientific books, were written at the time and for the following 2 centuries. The narrative is that what the Copernican revolution consisted on was to remove the Earth from being considered as the center of the universe and becoming just one more planet revolving around the sun. Here you have a representation of the world as it was known at the time of Copernicus from a German textbook. You have the Earth in the center and the Moon, and then you have Mercury, Venus, then the Sun, and then Mars, Jupiter, Saturn, and then the constellations, the 12 star constellations. Here you have a drawing from Copernicus' book, actually a drawing made by his own hand. Now we have the Sun in the middle. Again, remember what these names are in Latin: Mercury, Venus, the Earth with the Moon, Mars, Jupiter, Saturn, and then the constellations. Similarly, it is said that the Darwinian revolution consisted on having removed humans from being the center of creation into being just one more animal species. And then he accomplished first with the origin of the species, notice the rest of the title by means of natural selection, and then 12 years later by the descent of man, and of course with many other publications as well. So here we have a model representation of what Darwin did according to this narrative of the history of ideas. Now here we have humans, very closely related to chimpanzees, and then they're remotely related to the other primates. What I want to say is that this narrative is very unsatisfactory. What it says is correct, but what it misses is what is most important, and about these two scientific revolutions, which really must be seen as one scientific revolution with 2 stages, the Copernican and the Darwinian. To understand the Copernican revolution, one has to see it in terms of some of his followers, of which I have highlighted 2 who lived about 1 century apart from each other, from Copernicus, Galileo and Newton. What the Copernican revolution really consisted on was a commitment to the notion that the world consists of matter in motion, that it obeys laws that can be described, can be subject to test by observation and experiment, and that apply on Earth as well as in the heavens. So here you have quickly the portraits of Galileo and Newton, but most important for my purposes is to give two examples of what the Copernican revolution really consisted about, and like these two equations, force equals mass times acceleration, or the force of attraction between two bodies is directly proportional to the product of their masses and inversely related to the square of the distance. The Copernican revolution have left out organisms, and that left them out for a reason that has been elaborated through Christianity, through Christian history, but even by some of the Greek philosophers and of course in other cultural traditions. Namely, that organisms are clearly designed, and what is designed, there is a designer in a phrase that William Bailey will make famous. William Bailey was an Anglican, priest and Anglican minister, author of several books of theology, including natural theology, which Darwin read when he was a student at Cambridge, also moral theology, the book that Darwin studied. But his main distinction at the time was that he was a public speaker against slavery. He was an abolitionist at the time. Slavery existed in the United Kingdom as well as in many other parts of the world. In 1800, he became ill and he had to give up his public speaking career, and he decided to study biology because he thought biology had increased tremendously in his knowledge of the world in the second half, particularly of the 18th century. And out of this study came this book, published in 1802, Natural Theology. The book starts with William Bailey imagining that he's walking on a meadow with a friend and suddenly trips on a stone, and his friend asks him, where does the stone come from? And William Bailey said, I tell him that for all what I know, it has been there forever. There's nothing to explain. But imagine, he said, that a few steps later, we see a watch on the ground, and he asked me the same question. Obviously, I cannot give the same answer. A watch consists of many parts, all of them precisely integrated to make a functional little machine, so it obviously has been designed to serve this particular function. And then goes on into using the human eye as an example of an organ that is very precisely designed, and he points out all the different parts, the lens, the cornea, and the retina, where the signals are received, and the optical nerve, which I will point out to you because it will be relevant later, that it takes the information from the retina to the brain, but it has to cross the retina in order to reach the brain. So this is clearly this is something specifically designed for the particular function that it serves. And then the rest of the book is a very beautiful read, it's about 350 pages or so. And it's examples from different organs and parts of humans, and the relationships with the sexes, the relationships with other animals, animals with each other, and with the plants, and so on, as I said, for 350 or so pages. Well, it was Darwin's genius to show that design could be explained as the result of natural processes, process of natural selection, and therefore they could be integrated in the scientific revolution that had been started earlier by Copernicus and Galileo and Newton, as well as many others. We think of the origin of species as a book about evolution. It is not. It's a book about natural selection. Darwin at the time was planning to write a treatise of several volumes dedicated to natural selection, and he thought the origin of species as a summary of it. He says origin of species by means of natural selection, and actually the book has no references, no footnotes, just a summary that he wrote in a hurry for historical reasons that I will not go into. Eventually he never finished it. He never wrote the multi-volume book that he was planning to do. He published ideas in a number of different books. The first chapter of the origin of species is dedicated to the domestication of animals and plants, where he makes repeatedly the point that animal breeders and agriculturists can take advantage of variation that occur spontaneously in plants or animals and select animals and plants with properties that they want by reproducing, especially these organisms that have these variations. And here is the first time that he actually defines sort of formally natural selection. He is making the reference to artificial selection, practicing agriculture and animal breeding. And he says, seeing that variations useful to men have undoubtedly occurred, can it be thought improbable that other variations useful in some way to each being in the great and complex battle of life should sometimes occur? And can we doubt that individuals having any advantage, however slight over others, would have the best chance of surviving and appropriating their kind? This preservation of favorable variations and rejection of injurious variations I call natural selection. It's essentially the same process that now the variations which are advantages to the organisms themselves, helping them to survive better and reproduce more abundantly, and therefore these variations increase in frequency. The idea is in principle fairly simple, and he uses the first 8 chapters of the book to elaborate the concept of natural selection. And then in chapter 9, he says, as it were, well, if my theory is correct, evolution must have occurred. Now, evolution was widely accepted by the middle of the 19th century. But the point that Darwin is making is evolution must have occurred in a certain way, which is not the way it is generally accepted, which is the notion that organisms keep changing gradually over time. He says no, some organisms will change, some will not change, some will go extinct. Anyway, he uses then the evidence first from geology or paleontology, as we would say today, and the geographic distribution, 2 chapters to each one of these topics, and 1 chapter dedicated to comparative anatomy and embryology, and in chapter 14 comes back to natural selection and takes up the argument and the summarizes. So, briefly, and this is familiar here to all of you, or most of you, these are the 3 kinds of evidence that he uses. Of course, more recently we have added molecular biology as a great source of important source of evidence for evolution. In the first half of the 19th century, geology had come of age, and it has been argued convincingly so that when some parts of the surface of the Earth get exposed, and typically one discovers this strata, that this has formed at the bottom of the ocean and over time, and therefore the strata that are higher up have formed more recently, and therefore the fossils that are found more up in the layers of the strata are more recent. Those who are farther down are older. Here you have, this is from the Grand Canyon of the Colorado River. This is about 1 mile, more than 1.5 kilometers, and covering about 2,000 million years of evolution. Well, that would allow them to reconstruct the history of organisms. Here, the reconstruction doesn't come from Darwin, it is a simple one to illustrate the method that Darwin was elaborating in the evolution of the horse. The first animal is recognized as the horse is this little animal about the size of a dog, or Hiracotherium, and then we have evolution of the horses. Many things happen in size, number of toes, the habits of feeding and the like, and then the typical representation that evolutionists use when a new species arises. We show it as a branch, when it becomes extinct, the branch stops. And we can see there are times when there were many species of horses. And one thing that critics of Darwin brought up in his time is what they're called the missing links question. If fish have evolved into amphibians and reptiles into birds and monkeys into humans, where are the intermediates? Well, already in Darwin's life, in fact, 1 year after the publication of the Origin, the first fossil of this creature called Archaeopteryx was found in Bavaria, Bavaria, which is clearly an intermediate in many ways between a reptile and a bird. Because the skeleton is still largely like that of a dinosaur, but then there's other features which are more like a bird, including the feathers. Up to less than 10 years ago, a number of fish were known, including some shown here. I don't know, probably you can read them. That were starting to show some characteristics typical of amphibians, like apparently the beginning of some limbs. Then there were amphibians which still retain features of fish that were clearly amphibians with the 4 limbs, etc. Now, this, there was a gap between these clearly amphibian organisms and this still clearly fish of about 50 million years. Neil Shubin at the University of Chicago, with his own team, identified an area in the Inuit territory in northern Canada, where they found there were deposits that were about 770 million years old, and 370 million years old, and they thought that it was a good place to find intermediates between birds and amphibians. And indeed, after 3 years of work, they found this creature, Tactaric here represented. Well, not 3 years of work, it was work over 3 years. The Inuit territories, the weather is so miserable, they could work more than 2 or 3 months each year. But by now they have 20 fossils of 20 Tactaric animals. The intermediates that were primarily criticized as missing by people contemporary of Darwin were, of course, the intermediates between apes and humans. And at the time Darwin died, none of those intermediates we have gone here from the last common ancestor of chimpanzee to humans were known. Darwin was persuaded that they will eventually be found. And indeed, just a few years after his death, the first intermediate were discovered, which we call it now Homo erectus. The discoverer was a physician, a Dutch physician with interest on fossils, called it Anthropus erectus. Anthropus meaning monkey, Anthropus human, so ape-human erectus, because he knew, as a physician, he knew enough about anatomy to know that this animal, this individual, was walking on 2 feet. And he also noticed that the brain, not as large as a death of a human was definitely larger than the death of a chimp or a gorilla. Well, by now, as surely you all know, we have dozens and dozens of intermediate species between last common ancestor with the chimpanzees and ourselves, our species, having arisen only about 100,000 years ago. The split from the chimpanzees happened about 7 million years ago. And bipedalism was acquired relatively early. The brain was enlarged only more recently. Well, the evidence about geography, again, is well known, very particularly his experience in the Galapagos Islands, where there were different islands, different Galapagos. Galapagos is the Spanish word for tortoises, and the Spanish sailors that discovered the Galapagos. I was the bishop, Spanish bishop of Panama, who was in charge of a ship that discovered the Galapagos accidentally. And anyway, they found these enormous tortoises, and Darwin was fascinated by them and spent some time and energy studying them, and also collecting birds, these famous Darwin's finches, classified in these 12 species, and only one species exists in the mainland. Archipelagos, which are far away from the mainland, are remains one of the best ways to study evolution, because they have been colonized by very few organisms that are far away from the continents, which is where most evolution happens, because there's quite large masses are and the diversity of animals and plants. And those few organisms that reach the islands, the remote islands, then have opportunities to diversify because they have no competitors. And of course, no archipelago, no large archipelago, is more isolated than the archipelago of Hawaii, which is about 2,500 kilometers from where I live in Southern California, and with 11 islands, one formed within the last million years, about 800,000 years, volcano, Nucoa and Manuelea, about 300 to 400,000, and then we have still volcanic activity at present, going up to 6 to 8 million years in Hawaii. And what we find in Hawaii, and I'm using it as an example of this kind of evidence, is very few kinds of organisms. Those kinds of organisms are extremely diversified. I will start with Drosophila, the flies that people like myself and many others here have used in their research, or at least in their studies, the lab studies. There are about 2,000 species in the world. 500 are endemic to Hawaii. The land of Hawaii is, I would guess, less than 2% the size of Brazil, and yet it has 25% of all the species of Drosophila. Then you have these snails and mollusks, tremendously diversified and very similar, belonging to very small groups of insects. Here we have 3,750 species. That may seem large and very distant, but we know 750 species of insects have been described. So this is about 1/2 of 1%. And moreover, again, they belong to only a few groups, including the 510 species of Drosophila. And we have birds, no mammals. They never made it into the Hawaiian Islands. Then we have, again, the kind of evidence that in comparative anatomy, and I have this recent drawing, so Darwin, with the forelimb of a human, a whale, and then you have here a dog and a bat. Why these organs instead, these limbs, instead of so different purposes, will be made up of the same parts, organized in the same way? It's not a reasonable explanation. Clearly included from the common ancestors. It was already that the structures of the individuals came from the planet. intermediate between fish and amphibians that I was showing earlier. Well, let me spend a little bit of time talking about molecular evolution and the enormous impact the molecular biology had had in the study of evolutionary history and evolution itself. I identified 4 attributes of molecular biology which are what makes molecular biology so effective in the study of evolution, which I name precision, universality, multiplicity, and versatility. Very quickly, precision refers to the fact that the differences between two sequences of different organisms with a protein or now in the DNA sequence can be precisely counted. Let me show this by introducing the first major work of using molecular biology in the study of evolution by Waterfish and Manuel Marcolius, published in 1967. I was at the time young postdoc, actually young assistant professor, I believe, by the time this came about. And I can barely describe to you the impact that this had in all of us. Suddenly, Fish and Marcolius have shown that in the study of a single protein, small protein, that they could reconstruct the whole history of life. By the way, Waterfish was in the faculty of Guarujá in my department, College of Evolutionary Biology, for 25 years or so, and he passed away 3 or 4 years ago. Marcolius was working on cytochrome C, which is a small protein. He has selected a small protein to find out its structure, and the small protein, because it was so difficult to sequence to find out the sequence of amino acids that made protein at the time. And then Fish persuaded Marcolius to extend his sampling to species that will be very significant for his purposes. So here you have, again, something that all of you are familiar with, the way in which molecular biology, in this case the sequence of a protein, can be used to compare different species. You have in the top row the sequence of a human, in the second the sequence of a monkey, and the third the sequence of a horse. As you can see, schematic in color, there is only one difference between the human and the monkey, but there are 11 or 12 differences between the horse and the humans and monkeys. So we have this simple matrix, but if we look at 20 species as Fish and Marcolius did, here you have a sequence that represents each amino acid with a 1-letter symbol, and going from yeast all the way to humans. So they could count the differences. They constructed this matrix, fed it into a computer, and the computer gave them a phylogenetic tree as represented here. This is a model drawing, actually, mine from an article in the Encyclopedia Britannica, but there's the same phylogeny that they represented. So you have here the common ancestor of yeast and animals. Then you have a branch between the animals, common ancestor of insects and vertebrates, and then you have the fish all the way to humans and monkeys. Well, this phylogeny is far from accurate, and of course they knew that. But that's where we come to the second attribute of molecular biology, which is multiplicity. We have cytochrome C and other proteins. Now, what we do with DNA, the species of sequence DNA, the proteins are also more informative. So, there are thousands of genes and proteins. One can reach whatever level of accuracy one wants in reconstructing the evolutionary history of living organisms. it's a question of investing time and resources. Then you have versatility, which is a term I use to point out that there are proteins that evolve very slowly, like cytochrome C, which are very good to reconstruct the evolutionary history of organisms in the first 2 million years ago. Others, like hemoglobin, which evolve faster, and some which evolve very fast, like the fibrinopeptides, which are very good to study closely related species like the primates. Now, here you have the universal theory of life, which was published about 30 years ago, and again, this was done with a single gene, the ribosomal RNA genes, and it was enough to reconstruct the whole history of life, including bacteria, eukarya, and here you have this amazing that one single gene could provide so much information. Well, let me now use the final part of my presentation to look into what is called intelligent design, theory of intelligent design, something, again, all of you have heard about. After the decision of the federal judge in Arkansas and against the teaching of creationism in school because it was a religious doctrine, and eventually the Supreme Court of the United States corroborating that and therefore extending it to all the United States, a group of creationists really, invented this thing called the theory of intelligent design. That is, the idea that organisms are intelligently designed. By whom? They don't say. Because if they would say by God, suddenly the theory would become a religious doctrine. So as the judge will see, I will quote in a moment, of the trial that took place in the Central District of School District of Pennsylvania in the year, towards the end of the year 2005, for 6 weeks. The judge would ask the witnesses who were defending intelligent design, who is the intelligent designer? We don't know. It could be an extraterrestrial, or some genius who is living in the forest, or we don't know. So, of course, the judge, in a sensible person, makes fun of this answer. By the way, the judge, we will see in a moment, happens to be an appointee of President W. Bush and an evangelical Christian, not a suspicious character. And yes, he wrote a 120-page decision against the idea of intelligent design. So, briefly again, intelligent design, critique of evolution is wrong, is not science, is contrary to religion, and the main point that I am going to emphasize is this, that although they are presenting the intelligent design as an argument for religion, is really antagonistic to the extreme to religion, in my way of seeing it amounts to blasphemy. So, first, the critique of evolution is wrong. Here you have one of the, I think about the only bona fide scientist who has written about intelligent design, defending intelligent design, is Michael Becky, who is a professor of biochemistry at Ayala University. And in this book, he says there's evidence of design. How do we detect design? When an observer interacting with components are ordered in such a way as to accomplish the function beyond the individual components, the same argument as William Bailey. There is a difference. Becky knows about natural selection. So his argument adds what he calls irreducible complexity. So it says that the reducible complex system can only produce electric by slight successive modifications of every cursor system, not by natural selection. This is because unless you have all the parts, the system doesn't work. The eye doesn't work unless you have everything at the same time. So you cannot come by natural selection one step at a time. So here we have the eye. And here we have the, I am going to show you some examples of kinds of mollusks of elated patella, which the eye consists just a few cells sensitive to light and a few nerve fibers. These features are conic mollusks, very small. They're easy to see in the between the low tide in many of the coasts of California, and where you go and look carefully, you see these things that look like the regularities of the rocks, and when you stay put for a little while, you realize that they are moving. They are these limpets eating around, taking advantage of all the microscopic algae having brought by the tide. These creatures need to know only one thing: there is light or there is no light. If there is light, it's the low tide, time to eat. If there is no light, it's high tide, time to attach themselves to the rock. Since the time to take them to the open ocean, they will die. They attach themselves with such a strength that you try to pick them along. Even with a pocket knife, it's very difficult to remove them. Here you have another mollusk. The slit shell. This is a mollusk that has, as you can see, slightly more complex eye, you want to call it, or more. They can only see, in addition to them, whether they are being light or not, the overall direction of light. By the way, this mollusk is considered a delicacy in my native country, in Spain. It is very common there. It's called in Spanish the navaja. It looks like a pocket knife, Spanish navaja, and the two sides open and the animal comes out from there. It does not exist in the coasts of the United States. It exists also in China. It's also a delicacy. Here you have another mollusk, Nautilus. You can see now it's slightly more complex eye, and what I don't need to give too much. You can see motion, and you can see the direction of light. And this, by the way, is an example of an animal cited by Darwin, arguing its point of view of evolution. Nautilus, he says, the fossils that we have from several tens of millions of years ago are identical to the new ones. So they have not evolved, these morphological, they have not evolved. It refers to other fossils in Guarujá, other mollusks have not changed for millions of years. Then you have one more marine snail, and finally the octopus and the squids, who have a camera eye very much like ours. The very important difference is that in the evolution of the mollusks, the nerve fibers were forming in the outside of the retina, of the sensitive cells, while in the evolution of mammals, the optical nerve was formed inside the optical cavity. So, as I pointed out to you, and I called your attention to the fact that the optical nerve in humans has to cross the retina, and this is why we have a blind spot. Well, what squids and octopuses, in Spanish word, there are octopuses in Spanish word. Octopuses and squids have eyes as complex as ours. They don't have that effect, they don't have a blind spot, which implies, if the proponents of intelligent design are consistent, that love loves squids and octopuses more than he loves humans. They don't have that effect that we do. Well, here you have a summary of that argument. Well, the second point is intelligent design is not science. Here we have the judge, John Jones III, the one who presided this trial in Pennsylvania, in his decision on December 20, 2005, for 6 weeks, as I said, of having witnesses for and against intelligent design. And he says that without scientific justification, the mighty movement presents children with religious attachment must be done in scientific theory. The theory of intelligence cannot be tested because when one goes to Michael Beckett, the one scientist that has influence intelligence and science, how do you explain, for example, the different models between octopuses or squids and humans? And so, I don't know what the intentions of the designer are or were, so I cannot argue from that observation against intelligent design or against the creator or anything else. In any case, whatever the effects are, which are many in humans as well as in other organisms, and I will be mentioning some very briefly, they cannot be used as testing a hypothesis because, as they say, we don't know what the intentions of the designer are. We cannot test the theory. That is a theory, not science. In fact, there is not any evidence as I see there, any research, any hypothesis to test. We have a statement from Philip Johnson, at the time professor of law from Berkeley, who has written about the intelligent design through three books. And in an interview in January 1998, early in the history of intelligent design, he said, well, we don't have this, wait 5 years, and we will have experiments and results. The new scientists have never dreamed of. Well, 5 years went by, and 10 years went by, there's not a single piece of evidence supporting intelligent design. And my final point is that intelligent design is contrary to religion. It implies that it's incompetent, it's cruel, and blasphemy. We observe the effects of design. If we look at the human body, there's almost anything, any organ, any part of the body, that it is as well designed as an engineer would do it. You know, we have it's probably so important that intelligent design is playing with my machine. It's not working right. But I pointed out here a human jaw. It's not sufficiently big for the teeth, and so the wisdom did have to remove it in some places, and we got additional problems with the teeth and they have to be fixed. And we know why that happened. As the brain increases in size, the jaw has to reduce in size so that the head of the baby could pass through the canal of birth in the mother. So, the jaw became smaller, the teeth also gradually became smaller, but there were 4 organs in there that changed in the jaw, so they were always behind. And then of course we have the human birth canal, which is not good enough for the head of the baby, because we have such a big head, that made us intelligent and smart and accountable we are as a species. It seems a very problem giving birth. Have place of delivery. Then we have the 4 limbs, which I already pointed out, that are designed in the same way, made up of the same parts, to serve different purposes. An engineer would not design a ship, an airplane, and a car with the same components, more or less put together in the same way with slight modifications. So we have ID is contrary to religion and is I for imperfect or incompetent, really, not for intelligent design. Then we have the phenomenon of equality, which is so common in the world of life. The oddities like the praying mantis or the midge flies, where the female is the male after mating. It's a very common phenomenon, and it was many of the spider species do the male. In the case of the spiders, often as much as smaller than the female, mates with the female, walks in front of the female, and the female eats them. That's the best thing that the man can do for his genes. By the way, also in the case of the praying mantis and the mince flies, because in many of these animals, the females mate only once, and therefore the males and the average mate only once. If a male has mated with a female, he's not going to have other opportunities to mate. If it is eaten, now the female becomes stronger, has greater likelihood of producing progeny, which is healthy and numerous. Well, the phenomenon of parasitism is just very stunning. You have been mentioned in the sun. Why is there finally amongst bloodstream, in addition to all of that, think of the following, about 20%, probably more than 20%, at least 20% of all human pregnancies end in spontaneous abortion because the human reproductive system is so bad in the sun. 20% of all pregnancies, that's 20 million abortions per year. They are blaming God for that. Implicitly, obviously, they are not bad intentioned people. But implicitly, as I said, it amounts to bloodstream. So this is why I think evolution is Darwin's gift to religion, because it solves certain problems that the religions, at least the Abrahamic religions, have, in considering God as the creator and the designer of all religions. I myself wrote a few years ago, 8 years ago, this book, again, we moved to the last one before I wanted to show it, but the book is entitled Darwin's Gift to Science and Religion. Darwin's theory was a great gift to science. It was also a great gift to religion because it solved a number of problems that existed according to the theory of intelligent design, qualifications, stories, all the general narrative of the literal interpretation of the Bible, for example, which of course can be interpreted literally, and you can be seeing in evolution a way of solving or answering many of the issues that arise when the Bible is interpreted literally, or the theory of intelligent design is proposed seriously. Thank you very much.
I think we would all like to thank Professor Ayala for such a complete, well-rounded presentation. And I think we're going to leave it at that and go straight on to the reception from here. And so that all remains at this point is just one more time.